Good afternoon, guys. Week number 6. I'm going to start, as I always do, by giving you some feedback, and I have my notes right here. And then I'm going to cover chapters 10 and 11, which means that you have LO10 and LO11 due this Sunday at midnight. So just a little bit of information about the synchronous meeting. It went pretty well. We visited. You expressed what you like and what you don't like, which is always very helpful for me and for everybody else in this class and for future students that will take this class. One thing I want to mention is we talked about the city training, which is due at the end of this month. There's one person that has already submitted it, which is great. Another person sent me an email, and she included the link and the PDF, which is great. However, you know, based on our syllabus, that nothing is accepted through email, right? Everything has to be via Moodle. So when you finish the training, just copy and paste the link or the PDF, or both. It doesn't really matter to me because the link will take me to the PDF. And just go, I'll show you Moodle, just go where the training is, click on it, and instead of submit, that's your submission is the link or the PDF. That's what I'm trying to say. Now, LO8, 86%, and the same percent for LO9. I don't have any feedback on specific items, so that I cannot fault. It's not that you missed a specific question. To be honest, I would like to see those numbers going a little bit, to be a little bit higher. Again, as we said in that synchronous meeting, whatever you see in those questions is in the book. So look in the book. Hopefully the videos are helping too. So there are no surprises in those LOs, okay? Office hours tomorrow from 8 to 12:30. I'm going to include the link, as I always do, in that email that comes out with the link for this video. Yeah, and that's pretty much it. I'm going to go and share my screen and go to Moodle. So this is what we have for today, right? Chapters 10 and 11, validity, reliability, and animal research. What I was talking about the city training, it's right here. So when you go and do it, right, just go and submit as you would submit for any other assignment, okay? Just submit the certification of completion as a PDF or even as a link. I'll take it as long as it takes me to your certification. That's it, right? It is due on the 28th. You have time, just trying to be proactive so we're not rushing it and we're not stressing out. And also, you'll see that this is coming after this. So we're gonna, you'll already have some kind of basic understanding, but you'll see, I'm sure you'll enjoy it. You'll learn a lot, right? We all do as we go through these trainings. Now, I'm gonna go ahead and stop sharing this and start sharing the PowerPoint slideshows and start with our first chapter, which is chapter 10. Turn this on. All right. Veracity of data. I love that word. So what we're basically talking about is validity and reliability, right? I'm sure you've heard those terms before, and we're going to explain them today in terms of research that has to do with mainly exercise science. So at this point, reliability and validity has to do with how you design the study, how you collect the data, even how you are designing the analysis of the data, and definitely how it will affect the interpretation of the data. So we're not hitting a specific box of this process. Pretty much it has to do with almost everything, okay? All right. A decent amount of terms. Again, we're going to explain everything one by one, so hang in there. And as I always say, there's the glossary at the end, which offers a lot of aggregated information concerning each one of those terms. All right, let me take this. Okay. So before I start, I want to say that for the ones who know me, then you do know that I have a background in psychometrics. So here, yes, I'm gonna go along and use the terminology that our books uses, but I want you to remember something that we don't have valid instruments. We don't have reliable instruments either. Okay. Technically, what we have is reliable scores. And technically, what we can do is make valid inferences based on those scores. So the scores are reliable, not the test. And the inferences can be valid, not the test. Okay? Let me say that again. We have reliable scores, and based on reliable scores, we can make, most likely, valid inferences. I want you to remember that. We're going to go ahead and just explain everything the way our book explains them, but I just want to point that out before I even start. All right. It says here, I will be trying to define validity. An account is valid or true if it represents accurately those features of the phenomena that it is intended to describe, explain, or theorize. Another term, an agreement between two efforts to measure the same thing with different methods. The measure that the instrument measures what it is supposed to. It's pretty common, right? Something is valid if it actually measures what we intend to measure. That's something that even books have in as a definition, right? And a lot of people teach it that way, but I explain to you what's the right use of reliability and validity, okay? And are we measuring what we think we are, which is pretty much the same thing as the third bullet point. Okay. So in terms of education, we can use this term here. The extent to which a test measures what it is supposed to measure in the context of 3 points, the form of the test, the purpose of the test, and the population of whom the test is intended. Okay, we are going to break it down now and talk about different types of validity. These are not all, it's just some. Content validity. All right, so you're going to take a low 10 for this chapter, right? If a low 10 actually measures what is in this chapter, what is in this video, what is in this PowerPoint slideshow, we would say that it has high content validity. It's not something that there's a specific test to measure. Usually experts can have an opinion about it, right? And it's basically in educational or vocational settings. Now we talked about content validity. A lot of people will say that if the items are actually measuring what we were trying to measure, that would be content validity, and then that's the first step before going to construct validity. So it's like a prereq. So you'll see different kinds of explanation because a lot of people do not see the difference between content and construct validity. Construct validity now is a huge one. For example, we are trying to measure a construct, such as mental toughness, right? So humor, love, um, anything, something like that. And it is about the whole test. And it has to do with a specific construct. And there are specific tests to actually figure out if we have high construct or low construct validity. Okay. Now, criterion-oriented validity is we usually have, let's say, two tools, right? We have one that's a gold standard, like DEXA, and then we have a new one, and we're trying to see if the new tool, by comparing to the old tool, which is the gold standard, um, and by that comparison, we're trying to figure out if the new measure is good enough, valid enough, right? And that would be an example of a concurrent validity, which means, uh, let's say we have a new method, right? That new method is, I don't know, supposedly the caliber method is the new method, right? And we're trying to see if it actually measures body fat. And we have DEXA right now, which is a gold standard. We concurrently measure our body fat mass by the two methods, and we compare them. That will give us some kind of concurrent validity, happens at the same time. Predicted validity is when we use the scores of the test to make predictions about the future. So classic example we use is, can your SAT score predict your performance later in college, such as GPA scores? And that would be predictive validity. All these are types of validities. They're all useful. We're not going to go into a lot of detail, but it's good to have an idea of what validity is and some types of validity. Okay. Now, a lot of time we'll talk about regression, especially once we're doing some kind of analysis, and especially when we talk about the criterion-oriented validity, right? Have you ever heard about Pearson correlation? So a lot of times you'll see R equals something, right? And we'll talk about correlation in a little bit. That's Pearson correlation is a typical correlation that we see a lot of times. We're trying to establish a relationship between two variables, right? And when we have more, then we'll do multiple regression. And in multiple regression, for example, we're trying to create a formula that all these independent variables can predict this one, right? That's an example. So we may just have two, one independent, one dependent. We may have more. When we are talking about correlation, we want to talk about direction, the relationship, and about strength of the relationship. So let's say we're trying to find a correlation between weight and height, right? If we have a positive correlation, it means in terms of direction that if one goes up, the other one goes up, right? If we have zero, that means no correlation. We cannot reach a conclusion because we can't tell you if one goes. I mean, that's a conclusion. There is no correlation, which means that if one goes up, the other one may go down, up. Who knows? We cannot. There's no. The only thing that we can say about the relationship is that there's no relationship. Okay? Now, if it is positive, as I said, that says a lot about the direction, which means if one goes up, the other one goes up. If one goes down, the other one goes down. Okay. So the values can be from 0 to 1. The closer to 1, the stronger the relationship. So The number by itself will give us enough information about the strength of the relationship. So now you see, we draw a line so we can see graphically, and a lot of time we use graphs to have those visuals to help us understand a relationship, right? This is a positive correlation. You see why, right? Because the line is like this, which means if the weight is going up, the higher is going up. Negative, it should look the other way. So now, in terms of strength, the more parallel to the weight that line is, what happens? And then what happens the more parallel to the height is, right? So you need to understand, I want you to think about these two questions and understand, by seeing a line, what does it tell you about the strength, right? In general, the closer to one, the stronger the relationship. Can a relationship be negative? Yes, it will look like this. And here, what we know is we'll have a value which is below 1. It would be from -1 to 0. Again, 0 means in a relationship, the closer to -1, the stronger the negative relationship, which means the more one goes up, the more the other one goes down, right? So the relationship now is negative, as you can see here. Now here we have a number of pull-ups with weight, which means pretty much that the heavier you are, the less pull-ups you can do. Makes sense, right? So that's what this relationship tells us. And that's basic stuff, that's basic information we get from a graph like this. We've covered this before. Let's talk about it one more time. Correlation does not imply causation. So it just shows us a relationship. And I've given you some examples before, and I included Greece and stuff like that. I learned, and I hope you remember from previous videos. Whatever relationship two variables have doesn't mean that one is causing the other to go up or down. It just so happens, at least, that there is a relationship. The why of the relationship we don't know. And if we do not know the why, we cannot infer causation. Okay? Just remember that. Do not overinterpret your results. A lot of people do. Right. Another way to plot this to make it kind of more clinically relevant and show the significance of what we're looking at. Let's say we have two devices. We have device 1, device 2. Usually device 2 is a new device. Again, we can have DEXA and a new type of caliper, a kind of measurement of body fat mass. We can throw the 95 confidence interval up and down. So it's 0 plus 1.96 standard deviation and 0 minus 1.96 standard deviations. You see them over there, so you can see variance. And we have the line. You see on one axis, we have the average of device 1 and 2, and the other has a difference of those devices. And that helps us visually see how kind of close the scores of those two methods that we just used, how close they are or not. Okay, that's about it. Now, factors of affecting validity. If your criterion is the gold standard, if you're using DEXA, you should assume that that's a very good factor in terms of validity, right? If you are not using DEXA, but you're using something else, which is, let's say, not that well established, that may create issues with validity, right? So what you're using to measure whatever you're going to measure, even in your own proposal, that will affect validity. So if we can, of course, we should choose for the best criteria, the best tool, right? Population. If there is a lot of variation in the population based on sex, age, training status, injuries, anything about nutrition, sleep, that again affects validity in not a very positive way. And objectivity. Objectivity has to do with how you interpret. So if there are some standards out there that are already established, right? And you can say, oh, I found this score with DEXA. Is that a good score? Is that a bad score? Right? If we have some kind of standardized process to identify that's a good or bad thing, right? That is affecting our objectivity in a good way. So which affects our validity in a good way. All right? That's what I wanted to say here. All right, reliability. As I said before, reliability doesn't have to do, we don't have reliable instruments. We have reliable scores. But here we say reliability is related to the consistency. So if you keep measuring whatever you were measuring, you get the scores you're getting are very close. Okay? A test can be reliable but not valid, but it cannot be valid without being reliable. We say that, again, I don't like this kind of statement because, again, a test cannot be reliable. But what I want you to remember from that is a prerequisite of validity is reliability. If we can make valid inferences, in order to make valid inferences, we need reliable scores. We can have reliable scores and at the end mess up the inferences for whatever reasons, but we cannot make valid inferences if our scores are not reliable, right? So we cannot make valid inferences on body weight if our scores were not reliable, right? We can have reliable scores, but then we cannot make valid inferences concerning heart rate variability in something specific. So validity needs reliability. Reliability can exist by itself. Okay. And of course, we're trying to reduce measurement error because that affects reliability, and we'll talk about measurement error right away. Sources, participant. The participants have to be ready. There are some inclusion criteria. Some exclusion criteria has to do, for example, everybody has to come hydrated. For example, not having consumed caffeine in the past 3 hours, not having worked out in the past 48 hours, having slept more than 5 hours, not having hip surgery, hip replacement surgery, or whatever. By controlling all that, we'll have less error. Okay, and testing. No, testing can have to do with, let's say, the what's the word I'm looking for? The conditions. It can be humid, it can be hot, so that can affect, that can increase the error, or it can have to do with the test operator. I have to, let's say when we did EEG, we did an experiment with EEG, we had to test. We had to focus on testing, meaning on educating the test operators, which means we had to educate the 2 student research assistants that were involved in placing the EEG. Right? So that is important. We can change, like we're trying to keep the same test operator. So we're trying to keep some conditions the same because we are trying to not have error which will affect reliability. Scoring, of course, that's important. How we are, what kind of, again, has to do with the operator and how we are scoring the results we're getting. And the equipment, we always have to calibrate the equipment. We'll make sure, let's say we're using a bike or a treadmill, we'll have to calibrate before we start. That's or even the calipers have to be calibrated, right? How can we assess reliability? We have that intra-class correlation. And so here, let's say we already know that a test can predict something, and we're trying to see if another test predicts the same thing, or predicts it better. And with intra-class correlation, we can figure out if we need both tests or just one test. Okay, that's just an example. The SEM is something very popular. You may see it. That's the formula. If you see the formula, you see it depends on the reliability coefficient. So the higher the reliability coefficient, the lower the error, the SEM. Okay. All right. Some other method, test retest, is the degree to which scores are consistent over time. Okay. And here, let's say you went through some training, and now you're taking calibrate measurements, right? What do you know about the process? Don't you know that you have to rotationally do it twice? And if there's not a lot of difference, you're good. If there's a difference, you have to do it a third time. That has to do with intra-rater. So reliability has to do with the same rater. Differences that has to do with the same rater. Inter-rater is intentionally, we use 2 raters or 3 or 4, process the same thing, and we expect them to have to whatever they report to be close enough. Does that make sense? So that has to do with inter-rater reliability. And reproducibility. So here, whatever you propose to me to do, let's say you do it and you find this result. If somebody was able to do exactly the same, right, they should get very, very, very similar results. A lot of times people are trying to duplicate the study. And that's frowned upon in a way that, okay, somebody has already done it, or why do you have to do the same thing? But by doing the same thing and getting very similar results, that's how we pretty much confirm that a theory exists and the theory is valid, right? And it really adds on the literature. Although in the beginning you may think about it like, oh, we didn't do the same. We already know that. Well, we know that based on one person or on a group of researchers doing it. If more people do the same thing and they get the same kind of results, wouldn't that add a lot of power? All right, equivalent forms is when we have similar tools. So here, because you may remember what I asked you, let's say a quiz, I may rephrase the quiz and give it again to you 2 days later to see if I get similar results back. A very specific form of equivalent measures is when you translate it. That's something similar. When you translate something from, let's say we translated and we published that right from English to Greek, right? You have a specific form that supposedly collects information about mental toughness, right? So when you translate from English to Greek, Chinese, Spanish, it doesn't matter. You should be getting the same information, right? That's an equivalent measure. Internal consistency has to do with acquire multiple measures within a day, and we're trying to see again if they're consistent. So the same person may use we're trying to assess grip strength, right? So we may do that with your dominant and non-dominant hand 4 times the same day after we. So we know that you're going to get tired. We use the same protocol. Whenever you're ready, we use the same device, and we get some information in terms of us figuring out the internal consistency, okay, which is important. In general, we have a couple of suggestions about your research design. And when you're designing it, this is about an experiment, right? You have to have specific goals and specific objectives, what you're expecting. That is really important. When you're gathering the data or before you gather the data, and we did that with our EEG project, right? We did a test, a pilot, where we did the whole test with the EEG cap on, and we tried to see what we're getting. And that's how it's part of the education. It's part of the training, right? Of the persons who are going to get involved. So the more you practice, supposedly the less error you're going to get, right? So you're trying to, as you can see, increase reliability and validity. And piloting can definitely help with that. And when analyzing and interpreting the results, causality is maybe there or maybe not. It depends. If it's not, just explain the relationship. You don't have to explain why, and that may be important by itself. But if everything goes as planned, and there's, let's say, an intervention, and you were really careful how you design the whole experiment, how you gather the data, and how you analyze the data, yes, maybe it may be possible for you to infer causality. Right, and that's it for this chapter. We're gonna switch gears and we're gonna talk about animal research. Well, there are a lot of historical data here. One thing I want to say, I'm sure most of us love animals, and there's a huge debate on why we're using animals in research, and should we use animals in research, and how are we doing it, if we're doing it. And, this is not the course to, in a way, justify or not justify the ethical part. Even if I wanted to, I wouldn't be able to. I don't have an answer. I will explain what is going on. In general, this thing is based on pretty much the hypothesis that animals are more expandable than humans. Okay, and I guess if somebody has an issue with that statement, then he or she will have an issue with all this. Why we even use animals in research? But again, I just wanted to mention it. I cannot answer that question. I don't have an answer. I can tell the pros and the cons, and that's about it. Okay, this is not an ethics course, although this subject is wonderful for ethics by itself. Right. So here we're going to talk mainly about developing a study and what kind of sample you're using right here. Less terms. So we would use animals when using human subjects is not practical. When is that? As you can see, when we need large volumes of tissue and we cannot have it. When we need tissue that we don't even have in the human body, right? So when the intervention is dangerous or lethal to humans, and of course, if if the research or the results are going to affect mainly animals, so we're doing it for that. Here, then there's a lot more information in our book. There's a timeline of pretty much making a case that we've been using animals since forever. You see, even from Greece, and then you see Claude Bernard, who's the father of muscular physiology and Pavlov's dogs. Again, very popular example. And then he helped us with insulin, UCFDA, vaccines, all the way now to organ transplants. But the main idea we're trying to communicate from this slide is that we've been using animals since the beginning of research. Okay. And there definitely, it has gone through a huge process of trying to protect the animal, right? That started from 1876 in Britain. And nowadays we have the Animal Welfare Act, which an interesting side note, it doesn't include mice and rats, which is 90% of the animals that we use in animal research. So there's that. All right, so mainly, I hope you've heard about the Human Genome Project and how we tried pretty much to break down the DNA. And that opened a huge door for using more animals in the research, of course, specifically mice. You see a zebrafish, squid fly, depending on what kind of research we're doing. And we'll talk about that in a little bit. But again, the majority of these animals are mice or rats. And you can see all these animals helping the humans who are in the middle. And you see the specific type of research that they are going to be using. Now, we have when and if you would like, I haven't done any kind of research with animals. Mainly, first of all, because it's not something that has to do with sports psychology or strength training per se. So there are other people that I know though that they do, and the ones that I do know, they're using mice. Okay. So if you wanted to include animals, you have to submit your proposal to IACUC. And they are there in order to make sure that whatever you do is something that you really need to do, nothing more, nothing less. And they are really trying to protect the animals' rights. And they're trying to understand how this research would help humans, how much, and trying to understand if whatever you're expecting to find would benefit humans enough based on the number of animals, the way you're going to treat them, if the whole treatment would be lethal or not to the animals, and stuff like that, right? So what they're mainly looking for are three things: reduction, refinement, and replacement. Reduction has to do with sample size. And if the good thing with animals a lot of times is that they don't have a lot of variability in between them. So you don't need as many, when you compare it to human research, you would need more, right? So when we're talking about, I'm closing that parenthesis, but when we're talking about reduction is that if you need 5 mice, they will allow you to use 5 mice. You wouldn't use 7, you wouldn't use 6. Okay, so the fewer mice you could use, that's what they would accept. You have to make a case, okay? Refinement, as you can see here, has to do with whatever you do, you need to make sure that is as least painful, stressful, or whatever for the animal. It's not about torturing the animals, it's about putting them through something, right, in order to get some benefits. But that something needs to be designed in a way that the animals are going to be stressed or in pain as less as possible, right? And then replacement, you need to defend why you're using animals, especially nowadays when a lot of time we could use simulation through a computer. So if you could do that through a computer, they may not allow you to use animals, right? Here we have specific types of rats that are being used for specific research, and that's the only thing I would like you to remember from that. Okay, I don't really care about the specific types. Also, as you may understand, rice have been used mainly for endurance exercise. It's difficult to make them do resistance training. There are ways to do it, right? There are ways that like they can wear what is called. They can put some weight on them. I can't remember the exact word right now for some reason, or they can adjust some kind of weight on their tail, and they can make them move by giving them some kind of incentive like food when they push something or they go up a ladder, or they can kind of motivate them by scaring them like by some um, air, throwing some air in their cage and stuff like that. So there's some ways to do it, whether we agree ethical or not, right? And also we're interested in non-activity. So they can, another thing they do is just they suspend them from their tail. And you'll read about it in the book. Some of you may like it, some of you may not. Or they can mobilize them, or a part of them. Let's say they put a cast on one leg or two legs, right? And they're trying to see what is going on. These are large animals, and usually, the bigger the size, the more ethical concerns come from humans, from us. Here is a graphic that pretty much shows proportionally how many mice and rats we're using compared to other ones. So you see this is all mice and rats, and this small slice is represented here. So this is the amount, 90% is mice and rats, and this amount could be broken down into this, okay? And that was about it for today, guys. I want to wish you a great week. Before I do that, I remind you, no synchronous meeting this week, but we do have office hours tomorrow from 8 to 12:30. Spend a little bit more time in our book. I would like those scores and those alerts to get a little bit higher. It made me really happy, and I'm guessing you as well. And you need to submit LO10 and LO11 by Sunday midnight. All right, guys. So thank you very much. I'll see you soon. In the meantime, lift intentionally. No habits.